Hola guys, welcome to Matrices 10. In this short video of mine, I'm going to discuss about the transpose of matrix and its properties. We already saw the basic idea about the transpose of the matrix in the previous few sessions. In today's session, I'm going to more importantly discuss about its properties. I'm Srinivas and I'm here to help you all out to navigate through the maze of IPMAT Indore. Right. So let's first start by understanding the meaning of transpose. While I already mentioned it, I'm putting it out once again. Interchanging of rows and columns in a matrix is called as the transpose of a matrix. So if you notice, if you have a 2 by 3 matrix, this is a 2 by 3 matrix. Now, interchanging rows and columns means your first column becomes your first row. Your second column becomes your second row. Your third column becomes your third row. So a 2 by 3 matrix becomes a 3 cross 2 or a 3 by 2 matrix. This transformation is called as the transpose of a matrix. The transpose of a matrix is represented as A transpose. It is represented as A transpose. For a 3 by 3 matrix, because it is square matrix, it is symmetrical, the dimension does not change. But clearly you can see that the first column becomes your first row. Similarly, the second column becomes your second row. And your third column becomes your third row. Another example for you to understand is if you have a 3 cross 1 matrix. Basically, it is only one column and 3 rows. It becomes a 1 cross 3 matrix where your column becomes the row. So when you have a matrix A of dimensions A cross B or N cross M, then A transpose will become a matrix of dimensions M cross N. It will just reverse, right? So this is what is the meaning of transpose of a matrix. Okay. Let's go ahead and take a look at some of the matrix properties. So A transpose whole transpose is A itself. That is kind of obvious, I believe. When you replace rows and with columns and then again columns with rows, effectively you get back the original matrix. A plus B whole transpose can be written as A transpose plus B transpose. So the transpose can be taken inside the bracket separately. So you can add the two matrices and take a transpose of it, or take two independent transposes and add them. They are both the same. Now AB whole transpose becomes, here it's interesting, it becomes the reverse. B transpose into A transpose. The order is very, very important, guys. AB transpose becomes first B transpose comes in, then multiplied with A transpose. If you have more than two ABC whole transpose, then you will have to do C transpose in the reverse order, then B transpose, then A transpose. So when you have an overall transpose and you're taking it out of the bracket, the reverse order of multiplication and the transpose happens, right? The next property is transpose and inverse. A inverse whole transpose is equivalent to A transpose and inverse. What does it mean? It means if you have A inverse transpose, right? This is same as taking the A matrix, finding the transpose of it, and to this you take the overall inverse. So whether you take inverse and transpose or transpose and inverse, the order does not matter in this case. Obviously, this also is a very similar property, right? Because that's the same thing. You take transpose first and inverse, or inverse first and transpose. Effectively, these two are same. It's not different. Now, this is a property which is interesting to you. When you have a constant, K is a constant, 2 multiplied by A, and then you want to take the transpose, this is same as take 2 separately out and A transpose. Okay, so the 2 does not have any effect. You can take it outside. So first find the transpose of matrix A and then multiply it by 2 entirely, or K in the general term, right? And in the properties of determinants, we already saw the last property that I'm mentioning here. The property of a determinant does not depend on the original matrix or the transpose of a matrix. It is the same. A lot of these properties we will again use in solving of questions that have come in the previous IPMAT papers. So in the next class, I'm going to take up the last 2 years, that is 2019 and 2020 IPMAT question paper, and solve questions that have come from matrices. And you will notice that all the theory that we discussed till now is sufficient to solve all your questions that have come in IPMAT. Thank you guys. See you in the next session for problem solving.